discuss about dielectrics, which is one of the important topic. Dielectrics, especially the substances in which the electrons are tightly bound to the nuclei of the atoms. That is, in dielectrics, there is no free electrons. This is the basic difference between dielectric and a conductor. In conductor, there is a large number of free electrons are present, due to which the electrical conductivity of the conductors are so large. But in dielectrics, there is no free electrons. Due to the lack of free electrons, the conductivity of the dielectrics is very poor. Now let's see, when a dielectric material are placed in an external electric field, then what happens? Especially two types of atoms, molecules we are discussed here. One is polar atom and another is non-polar atom. Polar atoms are those atoms which the plus and minus, that is the center of positive charges and the center of negative charges, are slightly away from each other. And in case of non-polar atoms, they exist in a particular position, that is the center of plus charges concentration and the center of negative charges distribution are present in a particular point in case of non-polar atoms. But in case of polar atoms, they belong slightly different from each other. Let's see here, when no field is there, then we see here plus and minus charges are slightly away from each other. But when an external field is applied, then they are separated from each other, that is the distance between them slightly differ. Here we see that when an external electric field is applied, then all the dipoles are oriented along the electric field. As strong as electric field is applied, then most of the dipoles will be oriented along the field direction. Then there produces an internal electric polarization into the dielectrics. That is, the electric dipole moment per unit volume is called the electric polarization. It acts along this direction. EP is a electric polarization due to the dielectrics. Inside the dielectrics is present and an external electric field E is present outside. But this electric field EP, due to the induction produced inside the dielectrics, is slightly less than the outside electric field. Hence, being these two are oppositely directed, yet they do not cancel each other because it is slightly less than outside electric field. Hence, when a dielectric is present into an external electric field, then a net electric field is generated here, and this electric field is E vector equal to E0 vector equal to E vector minus EP vector. This acts inside the dielectrics. Then suppose we consider a conductor which is positive charges is to given to this conductor. When this conductor is placed in an external electric field, then from this conductor the electric field directed in this way. As the distance increases, then this electric field, the magnitude of this electric field gradually decreases. When a conductor is placed here, then there are so many numbers of free electrons are present. Due to this external electric field present inside the conductor, these free electrons feel a force in opposite to the electric field. F is equal to minus E into E. Suppose this is E vector electric field, then this force will be minus E into E vector. It will direct it in opposite to the external electric field. That is, suppose here is a free electron. These free electrons are loosely bound to the nucleus. Suppose this free electrons is displaced from this position into here due to this force, then here a negative charge is generated, and due to this movement of the free electron, here a positive charge is generated. In this way, lots of positive charges are generated inside the conductor, as well as negative charges are generated here. Since they are moves in opposite to the external electric field, hence a new electric field is generated here into the conductor due to the movement of the free electrons. This newly generated electric field will nullify the external electric field present inside the conductor, due to which there is no net electric field present inside the conductor, because the external field generated due to the movement of the free electrons and the field, applied electric field, will cancel each other, since they are in opposite direction. But in case of dielectrics, the electric field generated due to the polarization inside the dielectrics is slightly less than the external electric field E vector, due to which a net electric field exits into the dielectrics, and this is E0 vector equal to E vector minus EP vector. This is the some basic difference between a conductor and a dielectric. These are some dielectrics: mica, rubber, glass, etc. So today's discussion is some basic differences between a conductor and the dielectrics. Okay, thanks all of you to show this video and to get more updates. If you like, please subscribe my channel. Thank you.
Thanks for watching. Please like and subscribe. Thanks for watching. Please like and subscribe.